Hello. Today we're going to take a look at combinations of transformations. So we've explored some transformations already. We've looked at what happens graphically using Desmos. We've looked at what happens when we have the transformations given to us, or from the equation, can we represent what the transformation would be? We've looked at how we can find the transformation in terms of mapping notation. So we're just going to take a look at some more things that you need to think about when you're coming up with your transformations, and we're going to express them in different forms. So function notation, regular equation, we're going to look at mapping notation, and we're going to look to see what happens to the graph as well. So given this generic transformation again, or this generic function, what happens when we're given this equation to represent the transformations? Well, we already know a few things already. We know that the A value and the C value determine what happens to the Y coordinate. So this 2 here and the 1 here represents the transformations to the Y. Okay. We also know that the K value and the D value represent what happens with our X coordinate. So we know that in terms of our A value, which is the 2 here, that this refers to a vertical stretch. And it has a vertical stretch by a factor of 2. We know that our K value, not our K value, our C value represents the vertical, either a vertical shift, either up or down. So this tells us that we have a vertical shift, and because it's positive, that we're moving it up 1 unit. Now, what is different about this equation than the equations that we've looked at last week is that we don't have this middle bracket factored. So previously we've factored our K value has already been factored out of that bracket. In this case, it's not. So it's going to change what happens in terms of our horizontal shift left or right. So before we can go any further in terms of exploring our K value and our D value, we have to factor this middle bracket. So doing that gives us y equals 2f, which just represents the function. And then we're going to do a set of square brackets, and we're going to factor out the coefficient in front of the x. So it's -2, and then round bracket, x, and 6 divided by -2 is -3. Close that round bracket, close the square bracket, plus 1. So if this middle bracket is not already factored so that you have a number, which is your K, and then a bracket with your X and then your horizontal shift, then make sure you factor that out first. Otherwise, you're going to get your K value correct, but you'll get your D value incorrect. So that's important to make a note of. So now we can represent, or we can identify, the K value. So here is our -2. So because it's a whole number, it's actually going to be a horizontal compression. And it's the reciprocal, so by 1/2. We also know because it's negative that we're going to have a reflection in the x-axis. Sorry, not the x-axis, the y-axis. And lastly, the -3 tells us that we have a horizontal shift, and it's the opposite of what we think. So it's actually going to the right 3 units. So now that we've been able to identify all of our transformations that happens from this single equation, we can start to think about how we want to do this. Do we just want to identify our key points from our graph and just move them based on our transformation? Or do we want to use mapping notation? Okay. For this one, let's just move our points based on our transformation. So we know that we have a vertical stretch by 2. So here's my y coordinate of -1. So -1 times 2 is -2, so I'm coming down 1 unit. And then from here, I have a reflection in the y-axis. So instead of -5, I'm going to bring it over here to +5. Then I have a horizontal compression by 1/2. So instead of 5, I'm now moving to 2.5. I have a horizontal shift of right 3 units. So I'm moving it from 2.5 to 3.5 to 4.5 to 5.5. And then I'm shifting it up 1 unit. So it's gonna go right there. That's my first point. And that's a lot to sort of do. So that's why sometimes when we think about the mapping notation and we take some time to actually work that out, it makes it easier for us to not forget something. Okay, but let's take a look at the next one. So I'm starting at -3, -1. So I'm looking at my vertical stretch first. So from -1, it goes to -2 because I'm just multiplying that by 2. Then I have a reflection in the y-axis. So from -3, we're going to +3. Then I have a horizontal compression by 1/2. So instead of 3, it's actually 1.5 now. Then I have a horizontal shift right 3 units. So 1.5, 2.5, 3.5, 4.5, and I'm moving up 1 unit. So there's my second point. Then I move on to the next key point on my graph. So 0, 2. So 0, 2, well, I have a vertical stretch by 2, so instead of 2, it's actually going up to 4. And then from here, I have that reflection in the y-axis, but because it's already on the y-axis, there is no reflection. I have a horizontal compression by 1/2, but 1/2 times 0 is still 0, so it's still staying there. And then I have a horizontal shift by 3 units, so I'm going to move over 3 units, so 1, 2, 3. So now I'm at the point 3, 4, and then I vertically shifted up 1 unit, so now it's at the point 3, 5. My next key point, I start at 2, 2. I have a vertical stretch by 2, so 2 times 2 is 4. Then I reflect it in the y-axis, so it goes from +2 to -2. I shift it to right 3 units, so 1, 2, 3. So now I'm at, before I do that, I have to do my compression, my horizontal compression. So let's start over. So I'm starting at 2. I'm doing my vertical stretch by 2, so I'm up to 4. Then I'm reflecting, so I go over to -2. Then I have a horizontal compression by 1/2, so instead of -2, I'm going to -1. And then I move it over 3 units, 1, 2, 3, and then I move up 1. So there's my next point. So you can see how if you just forget one step, you could make a simple single error, which could affect what your transformation graph looks like. All right, last point. I have the point 5, -4. So from here, I have a vertical stretch. So I'm multiplying my -4 by 2, which gives me -8. Then I am reflecting in the y-axis, so I'm going from 5 to -5. From here, I need to do a horizontal compression by a half. So I'm going from -5 to -2.5. I'm shifting to the right 3 spots, 1, 2, 3, and then I'm moving up 1. So I'm at 0.5 and -7. So from here, I'm just going to connect my points. You would use a ruler so they're nice and neat. I'm going to actually make that a little bit lighter so that it's easier for you to see. There we go. All right, that's better. So I'm using a dashed line. You can use a colored pencil if that's easier for you. Make sure you denote the difference somehow, okay? All right, so that is one way that we've taken a look at the transformations. So first, identifying what all the transformations are. Remember, we had to factor out that middle bracket first, and then just use those transformations to come up with the missing points. All right, next example. So first thing that I want to do here is I'm going to factor out my middle bracket first before I do anything else. So I'm going to have y is equal to 0.5 f, which just represents this function here. And then that should be a square bracket. I'm going to factor out the negative, so a -1. That gives me x, and 1 divided by -1 is -1. Close my square bracket, minus my 2. So now let's this time use mapping notation. So if I start with my generic coordinate x, y, what happens to this based on my equation? Well, let's start with our x coordinate, okay? So we know that we have a reflection. So right here, this is our reflection. And we know the -1 is actually telling us that we have to move right 1 unit. So how does that affect my coordinate? Well, I'm going to multiply my x coordinate by -1, so -x, and I'm going to add 1. Now I'm going to take a look at what happens to my y. So I have a 0.5, which means that I'm going to have, this is less than 1, so I'm going to have a vertical compression by 1/2, or you could do 0.5, whichever makes the most sense for you. And I know that this -2 here tells us that I'm going to go down 2 units. So when I'm looking at my y coordinate, I'm multiplying my y coordinate by 1/2, and then I'm subtracting 2. So if I take a look now at my mapping transformation, or my mapping function or mapping notation, whatever you want, however you want to call it, then I can just take a look now at my key points and do that work first before I start to move my points. So I have the point -5, -1. I have -3, -1. 0, 2, 2, 2, and 5, -4. So you can do this in your head, or you can use a calculator, whichever works best for you and your mental math skills. So -1 times -5 is +5, plus 1 is 6. Half of -1 is -1.5. And -1.5 take away 2 is -2.5. Then I move on to my next coordinate. -3 times -1 is +3, plus 1 is 4. Half of -1 again, this is going to give me the same y coordinate of -2.5. Moving on to my next coordinate. -1 times 0 is 0. 0 plus 1 is 1. Half of 2 is 1. 1 take away 2 is -1. Next coordinate, 2, 1, or 2, 2. So 2 times -1 is -2. -2 plus 1 is -1. And I already know my y coordinate will be the same because it's 2's again. And then 5, -5, and then -5 plus 1 is -4. Half of -4 is -2. And -2 take away 2 is -4. So now these are the points that I'm going to graph on my Cartesian plane. So I'm going to go to 6 and then -2.5. Then I go to 4 and -2.5. I have 1, -1, -1, and -1, and then I go to -4 and -4. So I'm going to connect those. Again, that was a thick line. I apologize for that, but you get a sense of what it should look like. So let's just redo that. Again with the thinner line. There we go. That's easier for us to see now. So whichever method you like the best for today, feel free to use either mapping notation or just applying those transformations individually by each point. You can decide which works best for you. For now, on your quiz, which we will talk about when that will be, some of the questions may ask you to do one method versus the other. So make sure you know how to do both, but you can decide how you want to practice that. All right, let's do one more. So again, we need to factor out our k value first so that we have a correct horizontal shift. So 1/2, and this is where you're going to have to really think about, how do I divide by a fraction? So you're taking 2 and you're dividing by 1/2. Now remember, this is the same as multiplying it by, flip that second fraction, 2/1, and 2 times 2 is 4. So watch that. All right, so now let's think about our mapping transformation. So I'm doing the opposite of what we see here in terms of the horizontal stretch or compression. So it's actually going to be horizontal stretch by 2. So I'm going to multiply my x coordinate by 2 first. And then I'm doing the opposite of what it thinks like. So instead of moving to the right, I'm actually moving to the left 4. So I'm subtracting 4. And then for my y, I only have a reflection. So I'm reflecting it in the x-axis. So I'm multiplying my y value by -1. So let's start with our points again. We have -5, -1. -3, -1, 0, 2, 2, 2, and 5, -4. -5 times 2 is -10. -10 take away 4 is -14. And this becomes +1. Negative 3 times 2 is negative 6. Negative 6 minus 4 is negative 10 and positive 1. 0 times 2 is 0. 0 take away 4 is negative 4. And this is negative 2. 2 times 2 is 4. 4 take away 4 is 0 and negative 2. And lastly, 5 times 2 is 10. 10 take away 4 is 6 and positive 4. So you'll notice that I'm not going to be able to plot my first point because my Cartesian grid isn't big enough. So just plot what you can. So negative 10 and 1, negative 4, negative 2, 0, negative 2, and 6 and positive 4. So connect your points. Use a ruler so they're nice and straight. And this is the part of the function that we can see on this grid. You could, if you wanted to, we know that it should be somewhere over here. So you could extend that line a little bit if you wanted to go past the grid. So we're going to pause this video. You're going to practice some of the questions from the transformation exercises worksheet number 3. And then you're going to continue watching this video again for the next part of this lesson. Okay, welcome back. So now we're going to take a look at being able to figure out some transformations based on some parent functions that we already know. So we're not going to use some arbitrary functions now. We're going to use the quadratics, the absolute values, the exponential functions perhaps. We're going to take a look at square root functions and so on, okay? So how do we now apply these transformations to functions that we already know? So take a look here. We have this squared symbol right here. So this tells us that we're dealing with a quadratic function. So our parent function is y equals x squared. Sometimes your parent function will be called your base function. So that big chart that we had started to fill out initially will probably help you in terms of understanding what that parent function should look like and what are some of the key points that we need to think about when we're applying these transformations. Now, because this is a quadratic function and we already know how to graph a quadratic function when it's in vertex form, it may seem a little bit redundant to think about it in terms of what are those transformations, how does that relate to our first parent function, but I just want to use this as an initial one so that we can see and make sure that we're doing it correctly because it's something that you do know how to graph on your own. But let's start by plotting our parent function. So our parent function begins at 0, 0. We go over 1, up 1, over 1, up 3, and over 1, up 5. So based on our step pattern, 1, 3, 5, we do the same thing in the mirror. And then we're going to connect those using a straight line. Or sorry, not a straight line, a curved line. So here we go. Beautiful. All right. So this is my parent function, y equals x squared. So what are the transformations that are happening to this parent function in order for us to get this new function right here? Well, we know that there's going to be reflection in the x-axis. We know that we're going to have a horizontal shift. And we are shifting 3 units to the left. So it's the opposite of what you think when it's inside the bracket with the x. And we have a vertical shift six units up. So we can go ahead now and plot our new equation or a new graph based on our equation. So we know that we have a vertex of -3 and 6. And we know that it opens down with a step pattern of -1, -3, -5. And it mirrors on the other side. And if we take a look, yeah, that's exactly what we've done here. So we've taken this point, we've moved it 3 units to the left, 6 units up, and then we've reflected it in the x-axis. We can see that a little bit better when we look at the other key points, right? So this 1, -1 moves over 3, it moves up 6, and yeah, take a look at that, right? So it's now going to open down. So it works, okay, which is what we want to see, okay? So this is our new function right here. So this is y equals negative, and then x plus 3 squared plus 6. Okay, so now let's take a look at how we can apply this to any transformation. So we can write these transformations using any function notation. So if we write it this way, we can use any shape as a base function. So if I go back first to this equation here, we know that instead of writing it as y equals, we could write this as f at x equals, right? So f at x equals negative, and then x plus 3 squared plus 6. So now we're going to take our parent function. This time we want to use our base function or our parent function as the absolute value function, and we're going to graph it based on this transformation. So this is the same transformation that we did up in the quadratic one, but now we're going to see how it affects some other functions that we know. So we know that when we have an absolute value function, we start at 0, 0, and the absolute value function is really just 2 straight lines. So we're going to have 5, 5, and we have 10, 10, and on the other side we have -5, 5, and -10, 10. Okay. So this is what we have. This is what we're going to graph. Some 2 straight lines going up. So this is the parent function, y equals the absolute value of x. So what happens to this? Well, we're going to have the same transformations that we did up there. We have our reflection in the x-axis. So instead of opening up, this is going to open down. We know that we're going to have a horizontal shift. We're going to move it 3 units, and we're going to move it to the left. And we know that we have a vertical shift, 6 units, and we're moving it up. So my new function, so I'm going to take my coordinate here. The 0, 0 stays where it is in terms of the reflection. And then I'm going to move it 3 units to the left, 1, 2, 3, and then 6 units up, 1, 2, 3, 4, 5, 6. For my -5, I'm going to rotate it first or reflect it first So I'm going to bring it down here to -5, -5. Then I'm going to move it 3 spots to the left, 1, 2, 3, and 6 units up. 1, 2, 3, 4, 5, 6. I'm not going to be able to do my next coordinate because I'm going to run out of room on the left-hand side. So let's go ahead and do 5, 5 now. So I'm reflecting it in the x-axis, so it comes down here to 5, -5, moving it 3 spots to the left, 1, 2, 3, and then 3 spots up. 1, 2, 3, 4, 5, 6 spots up. And then lastly, I have 10, 10, so it's going to reflect down to 10, -10, moving it 3 spots to the left, 1, 2, 3, and 6 spots up. 1, 2, 3, 4, 5, 6. So this becomes the new function that I can graph based on those transformations. So you're going to go ahead and connect those. Put arrows on the end of your line to show that it goes forever in both directions. And this is your new transform function based on those transformations and our generic function, but we use the absolute value function instead. And if I wanted to write this in function notation, this would be f at x is equal to negative, and then my function is the absolute value, so x plus 3, close my absolute value, plus 6. All right, let's do those same transformations, but I now apply it to our square root function. So the parent square root function looks like this. We have 0, 0. We have 1, 1, 4, 2, and 9, 3. And we're only going to graph just the positive part of this function. Okay. So what are those transformations again? Well, we know that we have a reflection in the x-axis. We know that we're going to move it left 3 units. And we know we're going to move it up 6 units. So remember, the 0, 0 doesn't reflect at all. It stays where it is, but I'm going to move it 3 spots to the left, 1, 2, 3, and 6 units up. Here's my 1, 1. I'm going to reflect it first, so that's 1, -1. Then move it 3 spots to the left, 1, 2, 3, 6 units up. 1, 2, 3, 4, 5, 6. There it is right there. Then I go ahead at 4, 2. That becomes 4, -2. I'm moving it 3 spots to the left, 6 spots up. And lastly, 9, 3 becomes 9, -3 when I reflect it. Move it 3 spots to the left, 6 units up. So there's my new points. And as I'm going to connect those now in a nice curved line, it should look like this. If I wanted to express this in function notation, it would be f at x is equal to negative. Now my square root function, my x plus 3 goes underneath the square root sign. My plus 6 goes on the outside. And you can always label your parent function, which is the square root of negative x. The square root of x, sorry. Let's take a look at one more example. So same set of transformations, but this time we're going to apply it to a circle. So we know that r squared is 9, so the radius should be 3. So I'm now going to plot a circle from 0, 0, so that my radius is 3 units. And then you're going to do your very best to draw a circle that goes through those points. It's not going to be pretty, although you might surprise yourself. Okay, all right. So sometimes it's easier to think, again, we're thinking about our transformations first of all. So we know that yes, we're going to have a reflection in the x-axis. We're going to have a horizontal shift left 3 units. And we're going to have a vertical shift up 3 units, or up 6 units, sorry. Now, because it's a circle, if I reflect it in the x-axis, it's just going to reflect onto itself. So the reflection isn't going to change the shape or the look of that circle. So we're really just moving 3 units to the left and 6 units to the right. And we're not changing the radius at all. So sometimes it's easier to think about where's the center of your circle. So the center of the circle is 0, 0. So I'm moving the center of the circle 3 units to the left and 6 units up. There's the new center of my circle, and I know that my radius is still going to be 3. So I'm going to go over 3 units in all directions from that center of that circle. And sometimes that's easier to think about in terms of transformations with circles than looking at those coordinates, moving those coordinates. Obviously, if it was a vertical stretch or a horizontal stretch or compression, this would change. But because we don't have a horizontal stretch or a vertical stretch, we can just think about moving the middle of the circle and then using the same radius, because we're not affecting that. We're not affecting the radius of the circle because we have no vertical stretch or compression. I hope that makes sense. All right, so go ahead and try to connect those again using the best perfect circle drawing that you can. It doesn't have to be perfect, but as long as you get a sense of what it should be. So the black one is our original. This is our x squared plus y squared equals 9, and the blue one is our transform circle. So again, you're going to pause this video. You're going to try the questions on the transformations worksheet. And then when you're ready, then you can keep watching this video for the next part of the lesson. Welcome back. Okay, so the last part of today's lesson deals with transformations and function notations from the graph. So this time, instead of giving an equation and we have to come up with what transformations happen to that parent function, we're going to come up with a graph and see if we can make an equation based on that. So we're going to first have to think about, what does this graph most resemble? Well, if we think about all of our parent functions based on that large chart that we filled out last week, we know that this looks very close to the square root function. So my parent function has an equation, y equals the square root of x. So let's just go ahead and graph that. So 0, 0, 1, 1, 4, 2, and 9, 3. Okay. So here's my parent graph, or my parent function. Okay. Now, what happens to this parent function? Well, I know that there's going to be a reflection because obviously it looks like it's going in the opposite direction. So there's going to be a reflection in the x-axis. So when I reflect it in the x-axis, it's going to look like this now. And this is where if you have colored pencils, it might be helpful to sort of sketch the transformations that you're doing in each of those steps. And what happens to this equation? Well, it's going to be y equals the negative now of the square root of x. Okay, well that's not quite where we need it yet. So now we're going to have to think about what else happens to this graph. Well, I know that it looks like I'm moving it up. So I'm moving it up 1, 2, 3 units. So let's go ahead and do that next. So I'm moving this point up 3 units. I'm moving this point up 3 units. Okay. So I'm getting closer, but it's still not quite where I need it to be. So what would this equation be? So this is a vertical shift, 3 units up. And I'm going to, after my equation, I'm going to add 3. Okay. Still not quite where I need it. So maybe I'm going to think about, well, I have a horizontal shift now. So I have to move this 1, 2, 3, 4, 5 units to the left. Okay. So what is that going to look like? Well, I'm going to have this point here, 1, 2, 3, 4, 5. So I'm getting closer to where it needs to be. So I have a horizontal shift, and that was 5 units left. So how does that change my graph or my equation? I have the negative, the square root, and then the horizontal shifts go underneath the square root sign. And because I'm shifting it to the left, it's actually the opposite of what we think it is. So it's plus 5. And then after the square root, I have my plus 3. So now this is where you have to think about, okay, now what happens? So do I have a vertical stretch or do I have a horizontal stretch? Well, it looks like I'm going to have a vertical stretch. So I'm taking these points and it looks like I'm stretching them. And how am I stretching them? Well, it looks like I'm stretching them by every 2, right? So 0 times 0, this would have been my 0, right? So this one's not moving, but I'm moving this one, and I'm moving this one, and I'm moving that one, right? So it looks like I'm doubling that, doubling this, and doubling that. So this is 2 units, this is 4 units, this is 6 units. So it looks like I have a vertical stretch by 2. So now it looks like y equals negative 2, the square root of x plus 5 plus 3. And sometimes the stretches can be the hardest ones to think about, okay? But you have to think about what is happening from this point down to that point. What is happening from this point down to this point, and so on. Okay? All right, let's try another one. So what does this, let's go back here, first of all, and then how would I put this in function notation? This would be f at x is equal to negative 2, the square root of x plus 5, and then plus 3. Awesome. Okay, last one. So this looks like it starts with a reciprocal function. So my parent function is y equals 1 over x. So what does that look like? Well, it looks like 1, 1. It looks like 1/2, 2. It looks like 2 and 1/2. And then I would just connect those, getting close to my asymptotes, but not actually touching them. And it looks similar underneath. Okay, so I have an asymptote on my y-axis, and I have an asymptote at my x-axis. But where are my asymptotes moving to? That's the trick here, right? So it looks like I'm moving my asymptote over. So this becomes my new asymptote. And it looks like I'm moving my asymptote down. Am I doing anything else to this graph? Well, it also looks like I'm reflecting it in the x-axis, because instead of having it on the top right and the bottom left, I have it on the top left and the bottom right. So I have a reflection in the y-axis, and it looks like I'm moving it down 2 units. And it looks like I'm moving it to the left 1, 2, 3 units. But it doesn't look like I'm doing anything to a horizontal stretch or compression. So if I apply what I know now, my equation will have a -1 over x, instead of left 3, it's going to be +3, and then down 2, -2. It wouldn't matter if you put your negative down in the denominator or the numerator. If we think about that, this could have also been a reflection in the x-axis, because when we have a fraction, if we put the negative on the top or the bottom, it's still going to make this whole fraction negative. So we can just, a reflection in the y-axis could have also been a reflection in the x-axis as well, okay? So for the reciprocal function, reflection in the y-axis or the x-axis, it would look the same, right? So I'm either going down or I'm going side to side, okay? So the last thing that you're going to do is you're going to try some of the questions on the back of the sheet. And if you have any further questions, I can definitely help you out with those tomorrow.